Okay, Jai Hind everyone. I am Achintya Pandey, as an assistant professor in Department of Information Technology at Ajay Kumar Garg Engineering College, Ghaziabad. Okay, today I will discuss UML and UML diagram. Okay, UML means Unified Modeling Language. Okay, in my last video, I have discussed, object-oriented system concept. Basically, what are the object classes, inheritance, encapsulation, polymorphism, the what is object-oriented programming and the features of object-oriented programming. Today, I will elaborate what is UML, how we are going to model the software system before coding, and that comes under the UML. Okay. So, here we will explore the UML diagram for modeling the modeling which is done before the coding of a software system. Okay. So, we will explore the UML diagram for effective modeling. So, what is modeling? Before UML, why we model? So, what is the definition of modeling? The modeling is basically designing of software application before coding. Okay. It is an essential part of a large software project, large software projects, and helpful to medium and even small projects, because we simply represent before coding the system, the software system. We are going to represent how we are going to show all the essential things which is required just to complete or just to code just before coding the software system. Okay. So, unified modeling language is a graphical language for visualize and document models of software system, including their structure and design in a way that meets all these requirements, like visualizing, how it visualize when we model. Visualizing means graphical model with precise semantics. Okay. Specifying. So, specifying means models are precise, it should be unambiguous and complete to capture all important analysis, design and implementation decision. Okay. Then constructing, it can be directly connected to programming language which allow forward and reverse engineering. How we are going to document? So, diagram capture all piece of information collected by development team, allowing sharing and communicating the embedded knowledge. Okay. So, just to model before the coding, it needs various diagrams. So, out of these diagrams we can model the software system. Okay. So, even we could more diagram, more representation we could be there, but out of these 9 diagrams we generally model all the software system, most of the software system. These diagrams include object diagram, class diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, component diagram and deployment diagrams. Okay. So, even out of these diagrams we have the UML could be categorized into 3 major categories, that is the structure diagram, behavioral diagram and interaction diagram. So, in structure diagram it include class diagram, object diagram, component diagram and deployment diagram, while in behavior diagram we include out of all these diagram, out of all above 9 diagram, we have simply UML been categorized into 3 categories, and that 3 categories are structure, behavior and interaction diagram. So, structure diagram means structural parts. Okay. And that include class, object, component and deployment diagram. Okay. In behavior diagram, the use case diagram, activity diagram and state machine diagram been included. And in interaction diagram, it is simply included the sequence diagram and collaboration diagram. Okay. So, how a class interact with another class, how an object is going to interact with another object. So, that is done by the sequence diagram or sometimes collaboration diagram. Okay. So, there are 3 major categories. One is structure, second is behavior, and third one is the interaction diagram. So here we will elaborate various kind of these diagram by which we could represent or model the software system. So what is the class diagram? So in class diagram we simply use a rectangle. Okay, class consists of class is what? So class is a collection of similar type of objects. Okay, so class is you can understand class is a user defined data diagram. So this class is simply represented by a rectangle, and even the rectangle could have three sections. One section include the name of the class, other section include the member variable, that is data. Okay, and last section include that is the third section include the name of the functions. So here we have say for example, this is the class diagram, right? So this one is the class diagram, this one all are the class diagram. Here customer is a class, and these name and location are the variable, and send order, receive order are the functions. So by this way we could represent the class diagram. Okay, just for depiction we have simply use an example of order system of applications. So we will see, let's see, we are going to model an order system of an application. This is simple. We are going to design order system application. Okay, so how we are going to represent class, object, state, chart diagram, activity, collaboration, and all those diagrams. Let's see. We just by the we simply illustrate with this example, that is the order system of application. So it describes a particular aspect of the entire application. So first of all, order and customer are identified as the two elements of the system. These two elements means we are going to have these objects are different class. Okay, so one class is customer, another class is order. Even the order class is an abstract class, and this order could have could be specialized into two categories, that is the special order or normal order. So that could also visualize by looking into the concept of specialization or generalization. Okay, so this is the customer class, and this is the order class, and even order could have say we special order. Okay, like food processing, we can say food could be whenever a customer order, it could mention as a special order, whether it is special or normal order. So that's why order, even this class could be specialized into two categories, that is the special or normal order, and that is represented in UML by a triangle component, and that is called ISA, is a component. Okay, so we can say that this one is specialization and this one is in a bottom to top. Even for this class it could be generalization, and this one is the top to bottom is specialization. Okay, so this triangle component, and this is called a component. So whenever a class is going to have subclass or further divided, so that could be done by the specialization, concept of specialization. Okay, so now one class, say customer and order, they have a kind of association. One customer may have several order. Okay, so by this way, this relationship or this association is called one to many association. So by this way we could represent the class diagram of an order system or applications. Okay, then object diagram, object and class diagram both are similar. Both are represented by just a rectangle. Here the difference is we simply put the column. So this C is the object and this one is the customer. So both object and class are represented by the rectangle component, and in the object diagram we simply mention the name of object followed by class name, and in between we simply use a colon. This is the standard way to represent the object diagram. So before colon we could name the object name, and after colon we could name the class name. Okay, so here we have customer, class, order, like these all are the object O1, O2, O3. Okay. So number 12, 32, number 40. One is normal order. This O1 and O2. I mean number 12 and 32 are the special order. Okay. So object and class diagram both are similar. Just by in object we simply mention the name of object as well as the class name. Okay. Next one is component diagram. So in component diagram, component diagram are used during the implementation phase. Okay. I mean coding phase of an application. However, it is prepared well in advance to visualize the implementation detail. I mean, before drawing the component diagram, the following artifacts are needed. What are the file which could be used in the system? What are the various library and other artifacts relevant to that application, and the relationship among the artifacts. So here we could see like these all are, suppose we are going to model an order management system. Okay. So there could have multiple file like Java file. Okay. Like one page we could have a home page, say customer page, order. So these all are the different component we could have right. So in the above diagram we have 4 files are identified and their relationship are produced. So component diagram cannot be matched directly with other UML diagram discussed so far. Okay. So component diagram simply could be used to model the component of a system, to model a database schema, and to model the executable of an application, model the system source code. Okay. So all 4 functioning could be used just for drawing the component diagram. So here we could see like customer simply order. So the direction here like from customer to order, not from order to customers. So customer order. So there is a flow. Similarly, order could have a special order. Okay. And order could have normal order. So these all are the component. I mean, one is customer, second one is order, and special order or normal order. They all are a Java file and they are treated as a component. Okay. This is the deployment diagram of an order management system. In deployment diagram, various nodes are to be included, like from user to even post that application over the internet. So what are various components, like even user, the system over which user put does application, the modem, various kind of server, and all nodes, all similar nodes which could be used, they just come under the deployment diagram. Just for the order management system, we have user, we have a system, we have modem, we have internet, we have various kind of processor like caching server, and like suppose for these applications simply using 3 server. So these all considered as a nodes. So various nodes could be here in deployment diagram. Okay. So component diagram and deployment diagram are closely related. In component diagram are used to describe the component, and deployment diagram simply shows how they are deployed in hardware. Okay. The deployment means how it is deployed in the hardware. A component means even the software system. Okay. So what are the different files and all those, okay, are used in component. Okay. So deployment diagram are useful for system engineer, right? And efficient deployment diagram is very important as it control the following parameter like performance, scalability, maintainability, and portability. So before drawing a deployment diagram, we must require nodes and relationship among nodes. So like told, there are various nodes there could be used in deployment. They are included various nodes. From user to even the internet. Okay. So above shows a sample deployment diagram to provide an idea of deployment view of order management system. So we have shown nodes as a monitor, modem, caching server, and various servers. Okay. Next one is use case diagram. So use case diagram are considered for high level requirement analysis of a system. When the requirement of a system are analyzed, the functionality are captured in use case. Okay. So for the just order management system, we have a customer which is treated as an actor, and all those requirements like order, special order or normal order, these all are the use cases. Okay. This is the actor, and order or special order or even normal order, they all are the use cases. Okay. So in use cases, it is represented like these symbols. I mean these uh, notations. Okay. Okay, so use cases are nothing but the system functionality, right? The system are written in an organized manner. The second thing is which is relevant to use cases are the actors. Okay, so actors can be defined as something that interact with the system. Like here is the customer. Okay, so actor can be human user, some internal applications, or maybe some external applications. So when we are planning to draw a use case diagram, we should have the following item identify what are the functionality which could be represented as a use case, what are the actor and relationship among the use cases and actors. So these all representatives comes under the use case diagram. Okay, and this is the interaction diagram. Basically in interaction diagram, we can think it could have sequence and collaboration diagram. Sequence means from the initialization to the end. So this is the, this is the time reference. Okay, suppose here the object are the various classes are customer order, special order, or normal order. Okay, so let's see it is start at this point. So this is the initialization, then the functionality as send order. Okay, then order is simply confirm, then dispatch and all those. Okay, so this top to bottom show the timing from initialization to the dispatch or even the return. Okay, so how that this is the time time from start to end. Okay, so above diagram shows the message sequence for a special order, and the same can be used as a normal object. Okay, so basically interaction diagram has two things, or you can say sequence and collaboration, both are interaction diagrams. So in sequence diagram we simply have the flow, okay, from start to last, and in collaboration diagram there is also a flow diagram. Okay, like you can have but in collaboration diagram it is simply put the numbering, let's say 1 2 3 4 5. Okay, so we simply numbered. Okay, say initialization is 1, then the next step are number like second and so on 3 4, and so this comes under the collaboration diagram. So that is the main difference between sequence and collaboration diagram. Okay, like here initialization, customer, order, special order, end of process. Okay, so this is the flow of the application, order system application. So if we number simply, so this comes under the collaboration diagram. So in the collaboration diagram, the method called sequence is indicated by some numbering. Okay, we simply put the numbering like 1 2 3 4 or even A B C D like this. Okay, so these number indicates how the messages are called one after another. Okay, this is the state chart diagram where we show various states, like here idle state, like send or order request, select normal or special order, order confirmation, dispatch order. So these are the basically various state. Okay, so we simply have like initialization phase. So this is called initial state. Okay, then these all are the various states. Okay, and this one is the just like in automata where we put various steps from initialization to final state. Okay, so state chart diagram are very important for describing the states. It could be defined as a condition of object when a particular event occur. So before drawing a state chart diagram, we should clarify the following fact. We must identify the important objects to be analyzed, identify the states, identify the events and all, right? So this comes under the states. So here in state chart diagram, we have to think various step and states that could be represented like these above. Like these symbols. Okay, symbol. Notations. Okay, this is the representation. Like okay. Okay. Then we have activity diagram. So before drawing an activity diagram, we should identify the element like what are the activity, what are the associations, what are the condition and constraints. So these all comes under the activity diagrams. Like in the order management system applications, one activity could be like customer send an order request. This could be treated as an activity. This one is the initial point, that is the startup process. Then we could have order request system which confirm the receipt of the order. So this is another activity. Then these are the condition. Say order request system confirm the receipt of the order. So check, condition check, okay, whether it is normal or special order. So this is the condition check, which is represented by rhombus, okay. So just like in flow chart, even we represent a rhombus symbol for condition checking. Similar to that, here in activity diagram, we mention the condition by the rhombus symbol. And if it is yes, I mean whether it is the normal order, yes, then confirm the order. Okay, if it is no, then further it is just limited, I mean just confirm, okay, and dispatch the order. Once it is order is confirmed, simply dispatch the order, then terminate. If it is not, then we simply exit that, okay. So in activity diagram, we try to find out various activity which is performed in the application. So by these, I mean way, condition and all activity, we simply draw the activity diagram. So before drawing, we must notice what are the activity, what are the association, what are the condition and constraints, okay. So these all are the various representation way where we try to things are represented like following various diagram, and the important diagrams are all said diagram, 9 diagram by which we could represent the software system in a modeling way, okay, just to model the system, okay. So before coding, we simply model the system, and just for modeling, we simply use all those diagrams like object, class, activity and all those diagrams, okay. So this is a simple overview of UML, that is the Unified Modeling Language, okay. That's all. Thank you very much.